Okay, PB1 is RA2, PB2 is RB4, and PB3 is RA4. I, Xavier LaChance, will press PB1 for 3 seconds. Now I'll press PB2 for 3 seconds. Or 3 cycles, I guess, so 6 seconds. Okay, now I'll press PB3 for 2 cycles, so it should be around 16 seconds. Okay, and now we will press PB1 and PB2 at the same time. And we will let go. Now we will press all 3 at the same time. And let go. We're going to press PB1 again to ensure that there are no code hangups from previous states. And my IO state machine is in the function name IO check, and that is in the ios.c file, source file. Okay, so the code organization basically in the interrupt, this occurs whenever any button state is changed. And here we're checking if no buttons are pressed. And then this one is basically checking if the state is updated, it'll stop the timer of the blinking LED. Our timer 2 interruption is the LED blinking, and our timer 3 is a delay function for when we press one button to ensure that if we press 2 buttons, we get the correct button press state, I guess. And then in our IO check, we have all of the different state checks, and we have our switch statement for our delay functions and turning the LED on or off depending on what state we're in. So we keep the system in idle until the timer 3 delay has ended, and then the system basically idles, and the timer 2 never stops until it is called in until it is turned off by the CN interrupt here. So the system basically stays in idle until the CN interrupt is called, and then it'll stay in idle until the time delay is called, and then it'll be put in a state, and it'll stay in that idle state. The clock switching only happens for the frequency, the 4 second delay. So the only time it's ever switched is in, sorry, wrong function, this one. It's only, we just have a check in our delay millisecond function. And all group members contributed evenly. We worked on it together.